Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are encountering. In this video, we'll be looking at the topic relations and functions, and specifically the past paper questions from May 2019 until the present. Feel free to like the video and add any comments down below so we can help create other videos that will assist you in whatever areas that you're struggling in. Don't forget to look at the description down below where we have outlined the order we suggest that you go through the entire CSEC Maths syllabus for you to get a better grasp of the content and a better grade. Let's recap the 10 major topics in CSEC Mathematics, and this video deals with topic number 7, relations, functions and graphs. This question comes both in section 1 of the paper 2 and section 2. And in this video, we'll be looking at the questions that came in section 1. This topic comes for 8 questions out of 60 in paper 1, the multiple choice, and 20 marks in paper 2. May 2019, number 4b, part 1. Given that x is a real number, solve the inequality minus 7 is less than 3x plus 5, which is less than or equal to 7. So let's split up this question. So we look at the first inequality, minus 7 is less than 3x plus 5, and what we're trying to do is solve for x. So we want to move the plus 5 across from the right hand side to the left. It'll become minus 7 minus 5 is less than 3x. This gives us minus 12 is less than 3x. 3 is multiplying, so when we move it across, it will do the multiplicative inverse or dividing. So we will have minus 12 over 3 is less than x, which means minus 4 is less than x. Let's now look at the second part of the inequality. 3x plus 5 is less than or equal to 7. And we're doing the same thing, trying to make x the subject of the formula. When we move the plus 5 across, we will now get 3x is less than or equal to 7 minus 5. Notice we're maintaining the inequality signs. 3x is less than or equal to 2, so x is less than or equal to 2 over 3. Remember, the 3 was multiplying on the left side, so when you bring it across, it will divide. As such, minus 4 is less than x, which is less than or equal to 2/3. Part 2 of the question. Represent your answer in B part 1 on the number line shown below. So if we look at our number line, where we have 0, what we're interested in would be the values of minus 4 and 2/3. So let's look at minus 4. Minus 4 is not equal to x, but it is less than x. So that means that when we're identifying that, we're going to put a circle which is hollow or empty. Since minus 4 is less than x, it means that x is more than minus 4. So how do we indicate that it's more than minus 4? It means we're moving everything to the right of that minus 4 value. So if you take values of x such as minus 3, minus 2, minus 1, then they fit the inequality that minus 4 is less than those values of x. For the other side, we can say x is equal to 2/3. That means we're indicating that by a full or solid circle. And x is not just equal to 2/3, it's also less than 2/3. So it means everything to the left of 2/3. May 2019, number 4c. The equation of a straight line is given as x over 3 plus y over 7 is equal to 1. This line crosses the y-axis at Q. Determine the coordinates of Q. Well, let's write the equation. X on 3 plus y on 7 is equal to 1. And if it is cutting the y-axis, it means that the x value is 0. So if we substitute that, we're going to get 0 over 3 plus y over 7 is equal to 1. And if we look at this equation, there is only one unknown, y. So we can solve for that. So 0 over 3 is 0, so we can ignore that. So we're left with y over 7 is equal to 1. And if we want y, we need to carry the 7 across. It's in the denominator, or dividing. So when we carry it across, it will be in the numerator or multiplying. So y is equal to 1 times 7. So y is equal to 7. So the coordinates of Q, that point on the line where it's cutting the y-axis, the x value will be 0 and the y value is 7. Part 2. What is the gradient of this line? So let's write the line again. X on 3 plus y on 7 is equal to 1. And to work with it in a simpler form, let's try and get rid of anything in the denominator. So we'll multiply throughout by 21. So we'll get 21x over 3 plus 21y over 7 is equal to 21 times 1. That way, we remove all the numbers from the denominator. As you will see that 3 into 3, 1, 3 into 21, 7. So we get 7x plus 7 into 21 is 3. So 7x plus 3y is equal to 21 times 1 is 21. And now we want to make y the subject of the formula. So let's move the x across. So we're going to get 3y is equal to minus 7x plus 21. We want to get in the general form of a straight line graph, which means we only want to have y alone. So the coefficient will be 1. So how do we do that? We divide throughout by 3. So that will give us y is equal to minus 7 on 3x plus 21 on 3. And we can simplify that. So y is equal to minus 7 on 3x plus 7. So it looks like the general form y is equal to mx plus c. And what are we trying to do? We're trying to find the gradient. So the gradient is the m value, which is the number in front of the x, or the coefficient of x. So the gradient is minus 7 over 3. May 2021, number 4a. The diagram below shows two lines L1 and L2. The equation of the line L1 is x plus 2y is equal to 10. The line L2 passes through the point 0, minus 5 and is perpendicular to L1. Part 1. Express the equation of the line L1 in the form y is equal to mx plus c. Now let's rewrite that. X plus 2y is equal to 10. And what we want to do is make y the subject of the formula. So let's move the x across so that it will give us 2y is equal to minus x plus 10. And if we want y alone, then we need to move the 2 as well. The 2 is multiplying. On the left hand side, when we carry it across, it will divide. So it will give us minus x over 2 plus 10 over 2. And we can simplify that. That gives us y is equal to minus a half x plus 5. Part 2. State the gradient of L1. And if we look at that equation, y is equal to mx plus c, the gradient is the coefficient of x, the number which is in front of x. So the gradient, which is normally represented as m, is equal to minus a half. Part 3. Hence, determine the equation of the line L2. So when we say hence, it means that we're going to use some pieces of information earlier on in the question to help us solve. Now what do we know? We know L1 and L2 are perpendicular. And when two lines are perpendicular, it means that if we multiply the gradients, it's going to give us minus 1. So we can write that. Minus 1 is equal to m1, the gradient of line 1, times m2, the gradient of line 2. And we know m1, we just worked that out in part 2. So we can substitute that. We're going to give us minus 1 is equal to minus a half times m2. So we can take the 2 and carry it across, and the minus sign as well. So it's going to give us minus 1 times minus 2 is equal to m2. As such, 2 is equal to m2. That's the gradient of line 2. And if we want the equation of that line, remember the general form of the equation of a straight line is y is equal to mx plus c. We know m is the gradient of the line 2, m2. And we know c. If we look at the graph, we can see with that line where it is cutting the y-axis. So we can rewrite it, y is equal to 2x minus 5. May 2021, number 4b. Given that f of x is equal to 1/3 x plus 4 and g of x is equal to 3x all over x plus 1. So this means this is a relations and functions question. Part 1. Determine the value of f of 9. So what is that asking us? It's reminding us that we have a function. So let's write down the function that we have. F of x is equal to 1/3 x plus 4. And they want to know the value that this works out to be when x is equal to 9. So let's substitute x is equal to 9 into the equation. So we write f of 9. Wherever we have x, we're replacing it by 9. F of 9 is equal to 1/3 by 9 plus 4. And we can now simplify and solve. 3 into 3, 1, 3 into 9, 3, 3 ones are 3, plus 4. So f of 9 is equal to 7. Part B. Calculate the value of f of g of minus 3. So we have two functions. So this is called composite functions. So how do we solve for fg of minus 3? The first thing to do is to work out for g of minus 3. So let's write the formula. G of x is equal to 3x over x plus 1. And let's substitute g of minus 3 is equal to 3 by minus 3 all over minus 3 plus 1, which works out to be 3 by 3 is 9. So we get minus 9 over minus 3 plus 1 is minus 2. And the two negative signs will cancel. So g of minus 3 is equal to 9 over 2. So now we're going to replace the g of minus 3 by 9 over 2. So that gives us f of 9 over 2. So we repeat the same format as part 1. Write the function f of x is equal to 1/3 x plus 4. Substitute f of 9 over 2, which is equal to 1/3 by 9 over 2 plus 4. 3 into 3, 1, 3 into 9, 3. So we get 3 over 2 plus 4, which works out to be 11 over 2. Part 2. Determine the value of x for which g of x is equal to 5/2. So let's write the formula. G of x is equal to 3x over x plus 1. And we know g of x. That is 5/2. So let's replace it. So we're going to say 5/2 is equal to 3x over x plus 1. And we could put brackets around them. And now what do? We want to get rid of the items in the denominator. So we'll move the x plus 1 from the denominator on the right hand side and bring it across to the left. So it will end up multiplying in the numerator. And similarly, we could do that with the 2 as well and carry it across to the numerator. So we get 5 by x plus 1 is equal to 2 by 3x. And now we can expand brackets. 5 by x is 5x plus 5 by 1 is 5 is equal to 2 by 3x, which is 6x. And now we have an equation where there's only one unknown, so we should be able to solve that. So let's put all the x's on one side. So we have 5 is equal to 6x minus 5x. And that works out to be that x is equal to 5. May 2022, number 4a. The functions f and g are defined as follows. F of x is equal to 5x plus 7 and g of x is equal to 3x minus 1. For the functions given above, determine part 1, g of 1/3. So let's write the formula, substitute, and solve. So the formula is g of x is equal to 3x minus 1. And let's substitute. We know x is 1/3. So g of 1/3 is equal to 3 by 1/3 minus 1. And let's work that out. 1/3 of 3 is 1, so we get 1 minus 1. So g of 1/3 is equal to 0. Part 2. Determine f inverse of minus 3. So let's look at this little diagram we have here. And what is it they're really asking us? They're saying that we have minus 3 and we want to find the inverse function of that. So we want to find the x value, which is in the domain, which when we apply a function to it will give us minus 3. So we kind of working backwards. So f of x is equal to 5x plus 7. So we want to find f inverse x. So what do? We make x the subject of the formula. So we could carry plus 7 across. So we're going to get f of x minus 7 is equal to 5x. So x is equal to f of x minus 7 all over 5. And we can now replace it. Replace the x by f inverse x. So we get f inverse x is equal to, replacing the f of x by x minus 7 all over 5. And what do we want to find? We want to find f inverse minus 3. So we can substitute. So it'll be minus 3 minus 7 all over 5. And minus 3 minus 7 is minus 10. 5 into minus 10 is minus 2. So f inverse of minus 3 is equal to minus 2. So what that means is if we bring up minus 2 here and we apply the function of f onto it, it will give us minus 3. And if we do the opposite, if we take minus 3 and we find the inverse of it, f inverse of minus 3, it gives us minus 2. May 2022, number 4b, the line L is shown on the grid below. Write the equation of the line L in the form y is equal to mx plus c. So what they're asking us to do is find the equation of the line. So the first thing we can do is find the gradient of the line. The gradient, which is m, is equal to change in y over change in x. And there are many ways to do this. What I've found to be the easiest thing for my students will be drawing a right angle triangle to show the change in y and the change in x. So we can see, as we look at that red line going to the right, that if we start at any point on the line and we move across, let's say it starts at the point 1, and we move across 6 spaces to the right, and then we go up to find another point on the line, we go up 2 spaces. So therefore, the change in y is 2, the change in x is 6. So we can substitute that, m is equal to 2 over 6. So m works out to be 1/3, so we found the gradient of the line. And if we look at the line, where is it cutting the y-axis? It's cutting the y-axis at plus 1. So since the general equation for a line is y is equal to mx plus c, then we can substitute for m and c. So y is equal to 1/3 x plus 1. Part 2. The equation of a different line q is y is equal to minus 2x plus 8. Part A, write down the coordinates of the point where q crosses the x-axis. So let's write the equation that they give us, y is equal to minus 2x plus 8. And when it crosses the x-axis, that means the y value is 0. So we can substitute that. 0 is equal to minus 2x plus 8. And we now have a line with only one unknown, so we can solve this equation. So let's carry the minus 2x across. So we're going to get 2x is equal to 8. So x is equal to 8 over 2. As such, x is equal to 4. So let's bring that up on the graph. Therefore, this point where it cuts the x-axis will be 4, 0. Part B, write down the coordinates of the point where q crosses the y-axis. So let's write the formula again. Y is equal to minus 2x plus 8. And when it cuts the y-axis, what do we know? We know the x value is 0. So let's substitute that. Y is equal to minus 2 by 0 plus 8, which means that y is equal to 8. So let's bring up that point on the graph. So we now have qy is equal to 0, 8. Part C, on the grid, draw the graph of the line q. So since we have these 2 points, and it's a straight line graph, so let's draw the green line showing the line q. Part 3, last part of the question. Complete the statement. According to the graph, the solution of the system of equations consisting of L and Q is... So we have 2 equations. So the solution of these 2 equations, one equation being line L, which is in black, and one equation is line Q, which is in green. The solution will be what we're indicating with the blue arrow, the point of intersection of these 2 lines. And as such, the values are x is equal to 3 and y is equal to 2. We have now come to the end of CSEC past paper questions in the topics of relations, functions, and graphs. In section 1, in our first video in this playlist, we looked at past paper solutions from 2009 until 2013. In the second video for the next 5 years from 2014 until 2018, and in this video from 2019 until the present. Don't forget to look at the description down below, where we have outlined the entire CSEC Maths syllabus and the order we suggest you go through the solutions in order to get a better grasp of the entire subject area.